Hi there, how are you guys doing? We have already covered the concepts of simple machines, levers and pulleys, and today we are going to reinforce the concepts by doing some numericals. So have fun. While discussing the concept of mechanical advantage, we've seen that using lesser effort, we are able to lift loads which are heavy. For example, we may be able to lift a 100 Newton load by just applying 20 Newton or 25 Newton of effort with a mechanical advantage of 4. So is this by any chance violating the conservation of energy? Are we doing less work but at the effort side and delivering more work at the load side? So the answer is no, there is no magic out here. It's just that we are applying lesser effort, but the distance that is traveled by the effort arm is more, okay? Whereas on the load side, the load is more, the weight is more, but the load is traveling for a lesser distance. So the principle of the conservation of energy is not getting violated. It's just that we are putting less effort and traveling a longer distance, and more effort is traveling towards a shorter distance. And I hope many of you who have this question in your mind, it helps to clarify this. Now that we've learned the basics of simple machines, including mechanical advantage and pulleys and levers, let's get started with some numericals. So this is the first numerical that we have, which involves levers. What are we supposed to calculate? We are supposed to find out the mechanical advantage of the system, okay? So if you investigate this, the load is on one side, fulcrum is in between, and the effort is applied on the other side. So this is an example of the class 1 lever, right? So what is mechanical advantage? We know that mechanical advantage is nothing but the load that we are putting divided by the effort, okay? And from the derivation that we did, this is equal to the effort arm divided by the load arm, okay? Now in a class 1 lever, the effort arm is going to be the distance, this particular distance, which we can compute as 120 minus 20, which is 100, and our load arm is 20, okay? So we can say that mechanical advantage MA is equal to the effort arm 100 divided by the load arm 20, which is 5. So mechanical advantage of this system is 5. So if you see in the second numerical, these are the details that are given. They are telling that this is the lever system that is available, and they have given FA to be equal to 40 and AB to be equal to 60. And they have given a load in between. They are asking us to do two things. One, find out what kind of a lever system this one is, and also what is the mechanical advantage of this system, okay? So we've seen that the fulcrum is shifted and is from the center, it's on one side. That means this is not a class 1 lever. The effort is on the other side. That means this is a class 2 lever. So the answer for the first one is what kind of a lever this is. This is a class 2 lever. Once we identified, finding the mechanical advantage is easy. We must bear in mind not to get confused that this is the effort arm. The effort arm is always with respect to the fulcrum, right? So here we compute the effort arm as this. This is 40 plus 60 is 100. Load arm is 40, okay? So mechanical advantage, we use the same formula, is load arm by effort arm by load arm. And in this case, it is 100 divided by 40. That means we get the mechanical advantage as 2.5. I hope you follow this question. Now if you study this problem, they are mentioning that you have a uniform meter scale. Okay, so when you say uniform meter scale, two takeaways. One, the length of the scale is 100 centimeters. The second thing is, when they said uniform, the weight of the scale is always going to pass through the center of gravity, which will in a uniform meter scale be at 50 centimeters. Okay, so we can assume, we can take it as weight W of the scale is passing through the 50 centimeter mark. Okay, so what have they asked here? They have asked us to find out how many times W is greater than M. W is the weight of the scale, M is the mass that has been suspended. Given the fact that this system is in equilibrium, okay, we will take the moments. Okay, so the anti-clockwise moment has to be equal to the clockwise moment given the system is in equilibrium. So we say that W into this particular distance, this distance is going to be 10, is equal to M into this distance, right? So if this this has been given as 60 centimeters, so this is on the 60 centimeter mark, which means that this distance is 30, right? So we say this is M into 30. So if you take W by M, this will be 30 by 10 or 3 by 1, or we can say W is 3 times of M. Okay, so just by using the principle of moments which we have discussed earlier, we can find out that if the M is balancing this and keeping it in equilibrium, then the weight is going to be 3 times of the mass. So if you have investigated this problem, they are giving us the fact that the woman is applying a force of 70 Newton and that the mass of this bucket and water is given as 6 kg. And they are asking us to find the mechanical advantage of the system. Okay. They've also asked us to take G is equal to 10 meters per second square. Okay. So when we initially look at it, we may say this is a fixed pulley, and if a fixed pulley is there, mechanical advantage is 1. So we may be tempted to give the answer as 1 without actually solving the sum. We must bear in mind that pulleys are mechanical devices, so there may be some loss of effort because of friction, heat, sound. These are the different types of dissipative energies that are there. Okay, so we might have to apply in most conditions more effort than the load. Okay, so that is what we'll have to see. So what is the weight here? Given that the mass of this is 6, the weight is going to be mg. Mg is going to be 6 into 10, 60 Newton. Then we can say mechanical advantage is nothing but the load divided by the effort. So we have 60 Newton divided by 70 Newton. That means mechanical advantage of this pulley system is 6 by 7, which is less than 1. Okay. So the takeaways from here is that there is a certain amount of efficiency in the pulley system. Efficiency need not be 1. Efficiency can be less than 1 as well. And this is how we can compute the mechanical advantage. So if you investigate this problem, they have given that the person is using a 3 pulley system, okay, and he's using it to lift a load of 360 kg force, and they've also given the efficiency of the system to be 60%, and we are asked to calculate how much effort he has to put. So in this, when you are told 3 pulley system, you will have to remember that we will have two fixed pulleys mounted on the top block and one movable pulley on the bottom block. Okay, and the way we hook up the system is we start with the bottom block, go around the fixed block, come down, loop it over the top fixed pulley, and this is going to be the effort. Okay, so if you know it is a 3 pulley system, velocity ratio is going to be equal to 3. Okay, what is the velocity ratio? Just as a revision, what is the velocity of the effort and what is the velocity of the load? A comparison of this is what is called the velocity ratio, velocity of the effort by velocity of the load. And in an ideal system, we know that mechanical advantage is equal to the velocity ratio. This is when efficiency is equal to 100% or 1. Right? But if this is not an ideal system and if there is 60% efficiency as it is given in our case, okay, then mechanical advantage is going to be the efficiency multiplied by the velocity ratio. So this is an important concept that we need to remember. Mechanical advantage is equal to efficiency multiplied by the velocity ratio. So given the fact that velocity ratio is 3, I have written it as VA, it should be velocity ratio. Given that velocity ratio is equal to 3, we can calculate mechanical advantage to be equal to 0.6 times of 3, or it is going to be 1.8. Okay, so once we know that mechanical advantage is 1.8, we can very easily find out the effort. Okay, so we can use the formula mechanical advantage is nothing but the load divided by the effort, and in our case this is 1.8. Load here is 360, therefore effort will be equal to 360 divided by 1.8. Okay, so if you multiply this with 10, this becomes 18, 18 2s and 0. So effort has to be 200 Newton. Hi guys, hope you are having fun watching all these videos and learning important stuff. We are taking a lot of pains to make these videos especially for you. Be sure to give us a like and share it with your family and friends. They will also benefit from the effort that we are putting in. Subscribe to our YouTube channel and follow us on Instagram and Facebook. And we give important updates in our website www.cogitarelearning.com. So please visit and support us.